Class.
Hi, can you teach me relativity?
This is some bullshit.
Welcome back to the hypergeometrical universe theory. Today we will review how Who derives the laws of nature and unveil the meaning of the fine structure constant. As you know, in our prior videos you were introduced to the concept of the Silver Surfer paradigm for motion. The Silver Surfer paradigm for motion not only showcased the analogy between surfing and Newton's laws of dynamics and the HU Big Pop cosmogenesis, HU's theory of the creation of the universe. Who proposes that all particles in the universe surf the dilation layer. That's one of the two remnants of the creation of the universe. Here you can see the two options for modeling the extra dimension, be it time as in Minkowski spacetime or space, as in the hypergeometrical universe theory. You can see two options as the two geometric and hyperbolic tangent functions depicted below. When you apply Newton's law of dynamics, you get 1 plus tangent squared of alpha in the geometric version and 1 minus hyperbolic tangent squared of alpha in the Minkowski spacetime. Irrespective to the choice, the final result is the same. In other words, the real question is not if the space is hyperbolical or Euclidean. That's missing the forest for the trees. This means that the option of hyperbolic or Euclidean space or spacetime is arbitrary. The point is that when forces are carried by waves, the maximum velocity becomes the velocity of the waves themselves. That is a physical understanding of reality, and that overrules silly questions about the representation of it. The other point to be learned from these equations is that forces vanishes when the maximum absolute velocity c is reached. Quantum gravity. Who derives the maximum density inside a black hole using the idea the forces also go to zero when the maximum acceleration is reached. That happens when one goes from zero absolute velocity to absolute c in a single Compton step. That corresponds to have a 45 degrees change in 4D direction in a single Compton universe expansion step. The derivation of the laws of nature. Here you see a probe dilator and a large number of dilators interacting while the universe is expanding at the speed of light as a light-speed hyperspherical hypersurface. The quantum Lagrangian principle, QLP. As the universe expands, the fundamental dilator will move such that it dilates space in phase with the local dilaton field. That is a Lagrangian principle or no work by the constraints principle. By always being in phase, the fundamental dilator does not gain or lose energy. That only happens through dephasing. The kid on a swing. The concept of dephasing, QLP. Consider you pushing a kid on a swing. The amplitude will increase until it reaches a maximum. Without friction the motion will never stop, and if you remain in phase, you will never do or receive any work. That assures that particles don't dissipate just by existing. Epoch-dependent G. G is inversely proportional to the 4D radius of the universe. At each Compton step in the hyperspherical universe expansion, fundamental dilators have to move sideways by x to satisfy the quantum Lagrangian principle. Notice that the current 4D radius of the universe is 14.03 billion light-years and the wavelength of a fundamental dilator or the dilaton field is 1.32 femtometers. Notice that you can move sideways by x in two ways. First, you can twist your surfboard, change the angle between the 3D volume of the particle with respect to the normal to our 3D universe, to alpha 1. Second, you can scooch over the hyperspherical hypersurface and have the normal pointing along alpha 0. Those directions map to accelerations. Since we know the mass of the fundamental dilator, we can calculate the forces, electromagnetism and gravitation. Here you have the 4D view of the electromagnetic and the gravitational fundamental dilators. Knowing what we know now, the gravitational fundamental dilator shouldn't create any force and the dilator should just move to x without changing its 3D volume normal direction. Since the motion, sliding, takes place on a hyperspherical hypersurface with a 14.04 billion light-year 4D radius, The very, very, very small motion will cause a small change in the direction of the normal. That is the change in angle alpha for gravitation. From the picture it is clear that alpha is equal to x divided by r0 for gravitation and equal to x divided by lambda 1 for electromagnetism. We have already used the value for electromagnetism and that matched perfectly the empirical law of electrostatic, Gauss law. Notice that the dependence upon r0 means that g, Newton's gravitational constant, is epoch-dependent. What is the nature of gravitation? Gravitation is just a van der Waals force where the relaxation process takes place at 10 to the 24 Hz. This reflects the high frequency of the tunneling process. The higher the frequency, the more effective the dynamic screening will be. For this high frequency, the dynamic screening is almost perfect, making gravitation very weak in comparison to electromagnetism. In the context of van der Waals forces, the phenomenon is known as dynamic screening or frequency-dependent screening. This process refers to the rearrangement of charges in response to fluctuating charges in nearby moieties, which can dampen the correlation between these charges. Dynamic screening occurs because the charges in one moiety fluctuate at a certain frequency. If these fluctuations happen too quickly, the charges in the other moiety do not have enough time to reorganize and correlate with the original fluctuations. This limits the effective interaction between the charges and reduces the strength of van der Waals forces. Hence, in the hypergeometrical universe theory, gravitation and electromagnetism are already unified. They exist within a single framework and are described by the same Dilaton field. Gravitation is explained using van der Waals, a well-known model. Who also explains interaction of subatomic particles at intranuclear distances and electrons and nuclei in atoms. All those interactions are explained using the Dilaton field and the quantum Lagrangian principle. In fact, it is called quantum Lagrangian principle because in Who, the laws of nature are derived starting with a quantum construct, the fundamental dilator. This makes all laws of physics in Who to be quantum mechanical and relativistic. The Dilaton field of a single fundamental dilator. Description. Introduction to the concept of a Dilaton field generated by a single fundamental dilator, as per the quantum Lagrangian principle, where the fundamental dilator aligns in phase with the surrounding field, minimizing action. The Dilaton field is just a wave described by a cosinusoidal function multiplied by an envelope function that reduces intensity linearly with the number of cycles. Notice that for a large number of cycles, we get the physical meaning of the fine structure constant. The initial intensity, unitary or 1, is related to alpha by the 2 pi factor. In other words, the intensity of the Dilaton initial impulse is distributed around the circumference of the wave. So, alpha is the intensity density of the Dilaton energy. It will be showed that that density is also distributed within a micro-hyperspherical hypersurface. In other words, the spread of energy within a circular wave is homologous to spreading the same energy within the surface of a hyperspherical hypersurface. The micro part refers that the spread happens at each step. That happens because the only possibility of dephasing happens within the matter inside the hyperspherical hypersurface that is our 3D universe. Here we showed that the relativistic aspect of nature is a direct result of the light speed expanding hyperspherical universe, LEHU, topology. The Lorentz boost comes directly from the derivative of that tangent of angle alpha. The resulting effect is to weaken forces as they approach absolute light speed. Notice that one could choose to ignore that interpretation and recast it as time dilation. In other words, time dilation is an artifact hiding both the existence of the absolute reference frame and the weakening of forces. Notice that the boost factor contains the bias. The derivative of alpha with respect to r can be considered to be at zero velocity. In a single step lambda 1, there is a change of delta alpha. And that is how the derivative is calculated, just by dividing the change in angle, starting from 0 angle, divided by lambda 1. The dilaton field of n fundamental dilators, the dilaton field created by n fundamental dilators, highlighting the change in the effective wavelength due to interference. Notice that the envelope function has the same form as the envelope function for a single dilator. The reason is because no dilation ever produced lambda 2. The wavelength dependence upon mass is an approximation since dilator are not evenly spaced. The interference pattern of n dilators can be approximated by a single dilator with a higher frequency or smaller wavelength. Notice that the amplitude of the oscillation scale with the number of dilators because the dilaton wave is added coherently by each dilator. The large n approximation for phi_2 the dilaton field for a large number of dilator can be approximated by the envelope without the oscillatory factor. The reason is that fast oscillation makes the peaks too close to each other. Total dilaton field, the superposition of dilaton fields, summation of the individual dilaton fields to create the total field at position r, describing the overall effect of both single and collective dilator influences. Despite of the formula, the envelope should have a null derivative at r equals 0. For phi 2, here are the derivatives. Despite of all fundamental dilators dilating space with the same frequency and wavelength, the interference pattern can be modeled as a cosinoidal wave with a wavelength that is equal to lambda 1 divided by n. For such a fast oscillation, the crests are too close together and one can model the dilaton field as only the envelope. Derivation of the grand unification equation. Solving for r, we get the grand unification equation. This is the value the fundamental dilator, be it a gravitational fundamental dilator or an electromagnetic fundamental dilator, has to move sideways to obey the quantum Lagrangian principle, QLP. The difference between gravitation and electromagnetism will have to do with how the surfboard normal, 3D volume normal, is aligned with the radial direction. Notice that the bias of the derivation is built in into the 1 minus hyperbolic tangent of alpha squared factor. The delta alpha divided by dr or lambda 1 is biased at 0 absolute velocity. Here we calculate the Hu force by n dilators upon the single probe dilator and compare it to the expected force by Gauss law. This is done to confirm the value of alpha, the meaning of the fine structure constant. Here we equate the force imposed upon a single electromagnetic fundamental dilator to the expected value using Gauss law. From the comparison, we recover the value of alpha that is consistent with the current view. This confirms our interpretation of the physical meaning of the value of alpha. You might ask if that is not the same meaning as the one already proposed by the current view. It is not. Here I am talking about an underlying process, the dilaton field, instead of electromagnetic fields. This analysis is about metric waves with a wavelength of 1.32 femtometers. The physics is different and clear. What we call electromagnetic field is the envelope for an static field and a wave on the top of this finer metric wave for electromagnetic waves. Photons are undulations on top of the 4D dilaton field due to the oscillating fundamental dilator during emission or absorption. Hence, there is an underlying reality that the current view doesn't grasp. This is the meaning of the fine structure constant. It defines the rate of dilaton wave decay with the number of wavelength. The envelope of the dilaton wave decay with the number of cycles. The dilaton field total strength, 2 pi alpha, decays with its distribution across a larger wave. In other words, the value of alpha, 1/137th, is a relative value to the field at origin, at the fundamental dilator site. It gives you the measure of coupling between the coherence and the elastic space. This is an important departure from the current physics. In the current view, there isn't any underlying process. Here we consider the meaning of alpha when instead of circles, one consider hyperspherical steps. We realize that considering a step of lambda 1 doesn't explain the observed value. This means that within the value of alpha, there is information on the lifetime of each one of the fundamental dilator phases. Spreading the initial dilation impulsive intensity on a hypersphere corresponding to a single de Broglie step, one obtained the value 2 times pi squared or 19.7 instead of 21.8, the value of 1 divided by 2 pi alpha. Comparing that with the value of 1 divided by 2 pi alpha, one can obtain the value of the 4D radius. That 4D radius contains the space traversed by the universe while each fundamental dilator tunnels through their 4 phases plus the time it dwells on the phases, the phase lifetime. I considered all phases having the same lifetime. We can only see 2 of the phases. That is when particles interact. The 4D radius of the micro-hypersphere is 3.38% longer than 1. That implied that the universe interacts for only 1.69% of the time. We derived Gauss' law from first principles starting from the fundamental dilator and the dilaton field. We provided a new interpretation for the fine structure constant and unveiled an underlying reality that is not known. So, let's start modeling the dilaton fields and dilators interacting on distinct inertial frames. Notice that I am considering only inertial frames since any non-inertial frame can be construed as a sequence of inertial frames. The next step is to extend this derivation to moving dilators and